Hello, my name is Dominique Lauzon and I'm a Senior Application Engineer at MSC.Software. Today I'm going to discuss how the challenge of managing large complex finite element model assemblies, ensuring model quality, and capturing their associated results for easy traceability and work-in-progress visibility can be addressed using collaborative simulation tools. During a given product life cycle, stress analysts will usually initially obtain a conceptual geometrical design, which is then discretized into a finite element model to make a first-pass design capability assessment. This product can have multiple configurations, and each need to be validated and studied in order to obtain the best design. As a result, many parts will be manipulated, and thousands of results will need to be processed and verified and consolidated into a final certification report. Sometimes several design variants of each configuration need to go through evolutions and design cycles until the best design can be selected. A challenge arises when controlling the content of revisions, documentation, and the maintenance of relationships among the different types of data, from meshes, input files, results, images, movies, and reports. This makes collaboration among engineers difficult. Content is sometimes lost, wrong revisions are used, incorrect analysis are performed, and poor decisions are made, which causes major problems. Down the line, in the product development process, such a simulation data is usually revisited to be used as a validation of the manufacturing processes. It will also be used to perform test correlations or assess failures, either during test campaigns or during operation. This is usually where the ad hoc black book data traceability and management breaks down, creating an unfortunately common situation where engineers waste days and weeks of work unearthing old undocumented model built by others. For instance, they try to trace down a report margin to a specific load or geometry version, realize the model was of poor quality, or sometimes even end up recreating full assembly models. We will now see how analysts can use MSC SimXpert and SimManager to properly manage these complex assemblies, ensure their model quality, and capture their associated results automatically for better traceability and proper content management. Using SimXpert's Content Manager utility, also an enterprise gateway which we'll talk about later, our user creates a project and looks for the unorganized data in his hard drive. This utility now automatically organizes the content appropriately and defines revisions like version 1, version 2, etc. It also helps create appropriate simulation data relationships based on the data dependencies. Our user will now create two different configurations of his aircraft assembly leveraging the vast sets of parts. The first is an H-tail type configuration. He does this by writing out a simple expression that leverages the attributes of the parts that were defined earlier. He then does the same for a V-tail configuration, thus creating two different aircraft configurations from the same set of content with a few clicks. Next, he runs a template that performs some validation checks on the model to ensure quality. This template is also designed to populate the Content Manager utility with the data generated from the checks, building onto the already existing content shown in the Content Manager. The user can also capture and manage assemblies with reduced models or super elements and manage the vast arrays of loads and their respective results. Next, we see him sync up to the SimManager content repository and upload this entire content stack with a click of a Publish button. As it is being uploaded, each and every piece of content in that set is automatically tagged with extremely relevant metadata with information such as who created the content, when it was created, what sort of file it is, as a result file or an input deck or an image. This saves the user days of documenting this content with such information. SimManager automatically also recognizes the relationship and dependencies between the models and hence creates and maintains the relationships. Now any user with the appropriate permissions can view the content through a web browser, learn everything they need to know about the content through metadata, as well as find out which files came from what geometries or what results the processes produced, such as solver results files, images and values, movies, and reports. Moreover, now other users need not recreate content themselves or fish through their hard drives. They may simply use SimXpert Content Manager Enterprise Gateway utility to sync up with the SimManager server and retrieve the content directly. This way, this guarantees the content is version control, and SimManager tracks who uses it, when it was last used, which revision has been updated to, and due to the relationships created and maintained, the audit trail will always show the trailing breadcrumbs of the content. Also, the user will always ensure that he's working on the latest model revision and loads. Therefore, with SimXpert and SimManager, the analyst can now save lots of time organizing and managing their large assemblies, create large complex configurations quickly and safely, do model quality checks easily, generate results and reports quickly, without worrying about using the wrong content, losing a content, getting inaccurate results, and slowing down the progress. Also, managers can have work progress visibility into their programs through the SimManager web browser to help them make better decisions faster. Thanks for watching. If you'd like to learn more about how MSC.Software SimXpert and SimManager packages can help you manage complex assemblies, run automated process while seamlessly managing the produced content and their relationships, please go to our www.mscsoftware.com.